Good morning and welcome back again. I'm Miss Sandari and this is Science Equals Fun. Okay, we've finished Unit 1. Let's move to Unit 2. Unit 2 is talking about energy. Start by Lesson 1, Energy Resources and Forms. Why do we care about energy? We care about energy because we need energy in different fields in our life. Okay, can you name a certain field that doesn't require energy? You will not find. All fields require energy. So we need energy in different fields in our life. Okay, what is meant by energy? Energy, it is the ability to do work or to make a change. So energy, it is the ability to do work or to make a change. The measuring unit of energy is a joule. The measuring unit of energy is a joule. As human, to get energy, we are need to eat food. When I ask you give reason to get energy, you have to eat food. Why? Because the combustion of food in our body enables the body to carry out various activity. What is meant by carry out various activity? It means to do work. So to get energy, you have to eat food, and then you will be able to do work. Eat food, get energy, do work. Eat food, get energy, do work. Okay, and if you have noticed that when you are fasting and you just haven't eaten since a while, then you start to feel weak. You have no energy to do anything. So you eat food, you get energy, you can do work. Okay. This is for a human, but for a car, what is the energy for the car? How does the car get energy? The car gets energy by providing it with fuel. So we provide car with fuel. Why? So the combustion of fuel in the car enables the car to move. So we provide car with fuel. Why? Because the combustion of fuel in the car engine, of course, car engine, because the combustion of fuel in the car engine enables the car to move or to do work. So for human, you eat food, you get energy, you do work. For a car, we provide the car with fuel. Why? Because the combustion of the fuel and the car engine, of course, enables the car to move or to do work. What's the work of the car? To move. When a force acts on a body to move a distance or displacement in the same direction of such a force, it is said that work is done on such object. Okay, what do we mean by this sentence? Okay, look at this image. This man is you. Okay, you are pushing the car. Pushing is such a force. Pushing is a kind of force. Okay. And then we have the car and rocks on the car. Okay. Now, when a force acts on a body, the force is a pushing force from you. Acts on a body, the body here is represented by the car that's holding some rocks. Okay, so when your body acts a pushing force on this car, it will move in the same direction of pushing, of course. When you push it in certain direction, it will move in the same direction. Okay, here we say that you have done work. Okay, does it change, or there is a difference between pushing this car for 1 kilometer and pushing the same car for 2 kilometers? Of course there's a change or a difference. Okay, what is it? Okay, by increasing the displacement or the distance, the work done will increase. So by increasing the displacement, the work done increases. Okay, when a person affects a wall by force, he can do work. Why he can do work? Because the displacement equals zero. Okay, think about it. The wall, when you move or push the wall, does it change? No. Does it move? No. So the displacement is zero, and you can do work. So when you are pushing a wall, the displacement is zero, and the work, you can do work. We can conclude that work equals force multiplied displacement. The measuring unit of work is a joule. The measuring unit of force is Newton. The measuring unit of displacement is meter. So whenever you forget about the law of work, just remember, When you are pushing a ball, pushing is a force, and the ball the ball will move, so we have displacement. Okay, another example, when you are pushing a car, okay, pushing is a force, is a kind of force, and the car will move, so we have displacement. So work equals force multiply displacement. Another example, okay, when you are lifting maybe a toy or a book, lifting is a pulling force, and this book will move, so we have displacement. So work equals 4 multiply displacement. Calculate the work done when a force of 65 Newton. So we have the force. The force is 65 Newton. Okay, acted on a body to move it to a distance of 10 meters. 10 meters, so I have the displacement. So I have the force 65 Newton. Displacement 10 meters. What's left? The work. Work equals force multiplied displacement. Force 65. Displacement 10 meters. Okay, so work equals force multiplied displacement equals 65 multiplied 10. The result is 650 joules. So after we've talked about energy, work, force, displacement, now let's talk about resources of energy. We have multiple resources of energy. Let's talk about some of them. Now let's talk about resources of energy. The first resource of energy is the sun. The sun is a permanent resource of energy. Then we have the wind. You may ask yourself, a wind is a resource of energy? Of course. When the wind moves this wind generator, we get electricity. So the wind moves this wind generator and then we get energy. So wind is a resource of energy. And then we have fuel for cars, of course. So the first three resources of energy: sun, wind, and fuel. Let's complete with the resources of energy. Then we have food. Of course, we eat food to get energy, so food is a resource of energy. And then we have movement of water. Okay, water falls. When water falls, this gives us mechanical energy. So waterfalls are a resource of energy. Okay, and then we have nuclear reaction. Nuclear reaction is a resource of energy. So we have sun, wind, fuel, food, movement of water, and nuclear reaction. Now, after we've talked about the resources of energy, let's talk about forms of energy. Forms of energy. First, we have light energy. Okay, light energy is produced from sun, electric lamp, and kerosene lamp. The second form of energy, which is sound energy. Sound energy is produced from loudspeakers and musical instruments. And then we have electric energy. Electric energy is produced from wind generator and solar cell. So we have light energy, sound energy, and electric energy. Then we have chemical energy. Chemical energy is stored in food, car battery, and fuel. And then heat energy. Heat energy is produced from heater or gas cooker or oven. Then nuclear energy. Nuclear energy is produced from the reaction in the nucleus of an atom. In the previous lesson, we talked about the nucleus of an atom. So nuclear energy is produced from the reaction in the nucleus of an atom. Then we have mechanical energy. Okay, mechanical energy is stored in stretched spring and waterfalls. So mechanical energy is stored in stretched spring and waterfalls. So we have light energy, sound energy, chemical energy, heat energy, nuclear energy, and mechanical energy. Okay, that's all for today. If you have any inquiries, comment below, and thank you for watching. Bye.